Now, again, I'm going to do these because they're super critical for teachers, high council,
You guys know about the
overseers,
Putnam?
whatever.
It's a math competition for undergraduate
Well, changing
students.
rails.
It's a 6-hour long
They have
test
no
that
pattern
just
at
has
all,
12
and they
questions
behave
broken up into 2 different 3-hour sessions. And each one of those questions is scored
Now,
1 to
obviously,
10.
it's not the
The
cleanest
highest
model.
possible score would
But let's
be
take, I
101.
said hyperbole
And
was
yet,
the first model.
despite the fact that the
I mean,
only
it's going to
students
be all
taking
over
this
the
thing
road
each
here
year
for
are
what
those
this
who
hot
clearly are
nonsense
already
is
pretty interested in math. The
on
median score
what you're
tends to be
dealing with
around
here,
1 or 2.
two-dimensional, three-dimensional.
So it's a hard test.
Given
And on each one of those
kind of a
sections of
2D,
6 questions,
3D interpretation of real Bernoulli values to how logically to do that thing and why congruently and clean. Plus, you'll have to mark what is out there, right? You'll have to say,
the problems tend
Chaotically.
to get harder
You'll have
as you
to
go
say,
from 1 to 6.
What's
the
surprising is
logical
that
path?
for all sorts of functions
If
that
I
you might
said I
write
did
down,
this,
when you try to do something to visualize when possible behaviors arrive, results in some insanely intricate fractal pattern.
The most elegant solutions available.
Those of you who watched the last video have already seen one neat example of this.
See if I can find a
There's
good
this algorithm called Newton's method,
two-dimensional
which finds
models
the
of-
root
I'm going
of
to share
some
with you one
polynomial
problem
p.
that came up as
And the way it
sixth
works is to
question on
basically
one of these tests
repeatedly
a while
iterate
back.
the expression
And those of
x
you who
minus
follow
p
the
of
channel,
x
you
divided
know
by
that
p
rather
prime
than
of
just
x,
jumping straight to
prime
the
being the
solution,
derivative.
which in this
Oh,
case
for
would be
Bernoulli.
When your initial seed value is in the loose vicinity of a root to that polynomial, a value where p of x equals 0, this procedure produces a sequence of
Just
values
listen
that
to
is
3D.
really quickly
You're fine.
converges to that
You'll be-
result.
you'll-
This is what makes
quick
it a useful
kicking.
algorithm in
Quick-
practice.
I say quick kicking.
But then we tried to do
Anyway,
this in the
here's the
complex
question.
plane,
If you
looking
choose
at the
4
many
random
possible
points on a
seed
sphere
values
and
and
consider
asking
the
which root
tetrahedron
in the
with
complex
these
plane
points
each
as
one of
its
these seed
vertices,
values might end up
what
on.
is the probability
Then we
that the
associated
center
a
of the
color
sphere
with
is
each one of the
inside
roots.
Time.
that tetrahedron?
Remember,
And we
Lucy?
colored each pixel of the
Go ahead,
plane
take a moment
based
and
on
kind of digest
which
this
root
question.
a seed value starting at that pixel
You might
would
start
ultimately
thinking
land
about
on.
which of these tetrahedra
The results we
contain
got
the
were some of
sphere
these
center, which ones
insanely
don't,
intricate
how you might
pictures with these
systematically
rough
distinguish the
fractal
two.
boundaries
This is
between the
just
colors.
3 of them,
And
but I could
how
say
do you
it's
even approach a problem like
the
this,
math
right?
of it,
Now,
or
in this
computer
example,
engineering,
if you look
right?
at the function that we're actually
Well, it's
iterating,
usually a good idea
say
to
for
think
some
about
specific
simpler
choice of a
cases. So
polynomial,
let's knock
like
things
z
down to
cubed
2
minus 1,
dimensions, where
you
you'll
can
choose
rewrite the
3
whole
random
expression
points
to
on a
look like
circle.
one polynomial divided by
It's
another.
always helpful to name things, so let's
Mathematicians
call
call
these
these kinds of
P1,
functions
P2, and
rational
P3.
functions.
The question
And if you
is,
forget
what's
the fact that this
probability
arose
that
from
the
Newton's
triangle
method,
formed
you
by
could
these
reasonably
points
ask what
contains
happens
the
when you
center of the
iterate
circle?
any other rational function. And in fact, this is exactly what the mathematicians Pierre
I think you'll
Fatou
agree
and
it's
Gaston
way
Julia
easier to
did
visualize
in the
now,
years
but
immediately
it's still a
following
hard
World
question.
War I.
So
And they
again,
built up
you
a
ask,
surprisingly
is there a way
rich
to
theory of
simplify
what
what's going
happens
on?
when you
Get
iterate these
ourselves to
rational
some kind of
functions,
foothold that we can
which is
build up from.
particularly impressive
Well,
given
maybe
that they
you
had no
imagine fixing
computers to
P1 and
visualize
P2 in
any of
place,
this
and
the way they
Especially
do
off
it.
of that.
third point.
I mean,
I
what
think
you
this
would want.
distinguishes
Obviously, look what he's
Julia
doing
as
here. Pin it
play
in.
around
easily
with it
being
in
one
your
of the
mind.
greatest
You might
mathematicians
notice
of all
that there's
time
a
who
special
had no
region,
nose.
a certain arc.
But
Remember those
you
two
might be
things? Some of that
Bernoulli's
arc, the triangle contains.
By
Someone
far,
else.
the most
Otherwise
popularized
not.
example of a
Specifically,
rational
if you
function that
draw
you might
lines
study
from
like this,
P1 and
and the
P2
fractals
We
that
must
give
calculate.
is one of the
These lines
simplest
divide up the
functions.
circle into 4
Z
different
squared
parts.
plus c,
And if P3
where c
happens
is
to
some
be in
constant.
the one on the opposite
See,
I
here
side,
we're
guess
starting
that
from
this
Z.
is at least
Remember, we're
somewhat
not starting
familiar
from
to
Big
many of
Bang.
you,
We're
but
starting
it
from
certainly
now.
doesn't
The other
hurt to
arcs,
quickly
though,
summarize the
no
story
luck.
here.
This version
since
of
it can help
that
set the
right
stage
now.
for what comes
What's
later.
P1,
We're
P2?
assuming here
Ah,
that
This
all of the
game,
points
we're
of the
going to think
circle
of
are
c
equal,
as a
like
value
what is
that
it?
can be
What is
changed,
it?
What is the
and it'll be
probability that
visible as
P3
this
lands in
movable
that
yellow
arc?
dot.
It's
For
the
the actual
length of that
iterative
arc
process,
divided by the
we will
full
always
circumference
start
of
with
the
an
circle.
initial value
A
of
proportion
z
of the
equals
circle
0.
that this arc makes up.
So after
So
iterating
what
this
is that
function
proportion?
once, doing
Obviously,
z
that
squared plus
depends
c,
on where you put the
you
first
get
two
C.
points. I mean, if
If
they're
you
90
iterate a
degrees
second
apart from
time,
each other,
plugging in that
then the
value
relevant
to the
arc
function,
is 1/4
you
of the
get
circle.
c squared
Well,
plus
if I have
If
my
those
saw
2 points were
program
farther
out, or
apart,
actually
your
this
values
Gambit,
should be
and
some
I'm
kind of
going
of the
through
second
the
value
parts
moving
If
like
they were really
it's
close together,
like it's
that
my
proportion
code,
gets
like how
closer
to
to zero.
use the
You plug in that
code,
second
how to.
value to get
Think about this
z3,
for a
and
moment.
that third value to
P1
get
and P2 are
z4,
chosen
and
randomly,
continue on like
with
this,
every point on the
visualizing our
circle being
chain of
equally
values.
likely. So what is the average size of this
So if I keep
relevant
doing
arc?
this many
Pin
different
these
times
in.
for the first many values, for
Maybe
some
you
choices
imagine
Change them
fixing
around
P1
for
in
time
place,
mods,
just brings down all the
periods.
places you can still
Oh
see it all
yeah,
on the
soap
screen.
star.
and
All
other
of the
times it
possible
looks like it
angles
blows up,
between these two
and you
lines.
can actually show
Like,
that
Well,
if
I
it's
mean,
0
in
to
order to
2,
get it to go the way we want, we agree.
is
It's like
equally
absolutely,
likely.
but we could do this,
So
this, and
every
that. But the
proportion
entire class has
between
been
0
saying this.
Points of the plane where
Not
it stays
this.
bounded, black.
If to make augment in here, you'd have to know where to put a pin in it,
values
and then continue off of that line, because otherwise you are going to be doing a lot of grind. This thing's going to explode on you.
And that means that